are going to talk about Objective 30 today. We are going to solve problems involving direct, inverse, joint, and combined variation. This is a big SOL section. You definitely will see problems involving direct, inverse, joint, and combined variation. They have formulas that go with them. You need to memorize the formulas. The formulas are not on your formula sheet. Okay, so try to make a point as I'm teaching it today to memorize it. The other thing I will say is don't memorize, memorize the idea of the formula, but not the exact variables. Because like I'm going to be using when I'm teaching this, I'm going to be using X's and Y's. Don't get the idea that it has to be in that X and that Y every single time, because what happens when I throw like a H and a P in there? Like what happens when I use different variables? You get confused. So don't get stuck on just copying that exact equation. Understand what it means. Do you understand what I'm saying? Understand what I'm talking about. Okay? So let's start with direct. Y varies directly as x if there is some non-zero constant k such that y is equal to kx. And k is the constant of variation. Okay? So when I talk about two things varying directly, again, it may not be x and y all the time. It might be time, which would be t, right? And your grades. Let's compare time studying to your will. The more you study, what happens to your grades? Grades go up. You can reverse that. The less you study, the less you do homework, grades go down. It's a direct variation. If one goes up, the other goes up. And if one goes down, the other goes down. So I want you to understand that if two things vary directly, they follow each other. If one goes up, the other goes up. If one goes down, the other goes down. Okay? I want you to also think of the word multiplication or times. When I see directly, I want you to think that the constant is being times to x. Okay? So if y varies directly as x, the constant is being times to x. So it might say something like this. Y is equal to 3x. 3 would be the constant, which means it happens every single time you happen to be timesing by 3. In this particular instance, like if I had this table, 1, 2, 3, 4. If I'm timesing by 3, I'm going to times each x by 3. So 1 times 3 would be, what would the y be? 3. 2 times 3 would be? 3 times 3 would be? 4 times 3 would be? So with those particular points, that's a direct variation because you're timesing by 3, timesing by 3, timesing by 3, timesing by 3 every single time. And that's constant. If something is constant, what does that mean? If I constantly do something, it stays the same and I'm doing it all the time. Can you give me other numbers that in particular formulas, it's that number every single time? Like in geometry, what constant do you use all the time? What number do you use all the time when dealing with circles? Pi. That is a constant. Is it always pi that you times by? Like pi times the diameter equals the area. Is it always pi that you are timesing by? Yes. Pi would be a constant because you're timesing by that number every single time. In chemistry, do I have anybody in chemistry yet? Anybody done chemistry? there's something called a mole, okay? And you use that mole, that number, every single time that you work with that particular type of equation. So just know that if it's a constant, then that's the number that for that particular equation, you're multiplying by that number every single time, okay? So let's put this into action. If y varies directly as x, and y is 9 and x is 6, I want to find y when x is 8. So, first of all, if this is the SOL, how do I know that this is direct variation? How do I know that this is a direct variation problem? Because it says what? Directly. I mean, it's pretty obvious. It says varies directly. Will it always tell you what kind of variation it is? I would say 98, 99% of the time. I mean, there might be that one smidgen where you have to like look at it a little bit further to know what kind of variation it is. But this one, you pretty much know that it's direct. Okay, it will tell you this varies directly, this varies inversely, this varies jointly, this is combined. Okay, so y equals kx. If it's direct to x, that means it's timesing by x. Okay, the constant is being times by x. So today's lesson is kind of like what we did with our sequences and series. What was our motto? Plug in what we know, solve for what we don't know, and then use that to answer the question. So we're going to kind of go back into that as well. So part 1, this is the first information. This is part 1. We know y is 9 and x is 6. So what can I do? Plug 9 into y and plug 6 into k. So plug in what we know. What do we not know? We don't know the k. So how would I solve for k? I'm going to divide by 6 on both sides. So what's my constant in this case? 9 divided by 6 is 3/2. Very good. That just means that I'm timesing by 3/2 every single time. Times by 3/2, times by 3/2, times by 3/2, times by 3/2, because that's my constant. Okay? So, plug in what we know. Solve for what we don't know. Then we're going to use this to go to part 2. Here's part 2. So y equals kx. So k is 3/2 and x is 8. So what can we solve for now? What would y be? 12. Very good. So y is 12. So any questions about part 1, part 2? Plug in what we know. We solved for the k. Then we use that to plug into part 2 and solve for the missing variable. So you try this one. So I know that this is direct variation because it tells me varies directly. And I know the equation for direct variation is y equals kx. So y is 5, x is 15. Any questions on, there's part 1. So plug in what we know. We can solve for k. So when I solve for k, what do I get? 1/3. Very good. Now I'm going to use that with part 2, y equals kx. And let me see, y is 9, k is 1/3. You got to be careful. Plug in for which variable you know. How would I solve this for x? You could totally divide by 1/3. How many divided by 1/3? Miss Corns, I like to multiply by the denominator and times by 3. So you get 27 is equal to x. Either way is fine. You can divide by 1/3. How many times by 3 with me? Attaboy. All right. Any questions? All right, so let's go to inverse. What did I tell you direct meant? What word? Times. I want you to remember that direct means times. Inverse is the opposite. So if direct means times, what does inverse mean? Divide. So notice the constant is being divided by x. If direct, the constant is being times by x. Inverse, the constant is being divided by x. Okay? Notice that there is another question or another equation over there. xy equals k. What's the relationship? Are these the same equations? Are they the same? Why are they the same? Okay. Okay, so here's what I'm going to say. This one is solved for which variable? This one's solved for y. This one's solved for k. They're the same equation. They're just solved or rearranged for different variables. Like, for example, if I had this and I wanted to, let's say I want to solve it for k. What would I do to both sides? I would times both sides by x, and I would get xy equals k. Oh, I just rearranged it and got that equation. So here's what I want you to understand. These equations can be every shape and form. You need to take, like, know, if I were you, I would memorize this equation right here. Know that equation is inverse, but be able to do what with it? Flip it around. Maybe you solve it for k and get k equals. Maybe you flip it around and get x equals instead of y equals. Does that make sense? You need to, because they're going to like pop you up a question and they're going to say, which of these represent joint variation? And you would have to say, okay, that one's joint variation. And then that one's the same thing as that one, except it's solved for a different variable, so you'd have to choose it. And then this one is the same thing as that, but it's solved for this variable. Like, you're going to have to be able to flip it around and solve it for different variables. So memorize this one. This is the one that I would play off of, okay? This one right here. Direct, k is being times by the x. Inverse, k is being divided by the x. That's how I would memorize it. But then be versatile with it. Be able to flip it around if you need to put it in that form. Okay? So, let's look at example 3. If y varies inversely as x, and y is 12 and x is 10, find y when x is 15. So, part 1, part 2 again. How do I know that this is an inverse equation? Because it says inverse. Yeah, most of the time it will tell you what it's wanting. So y is equal to k divided by x. So part 1, part 2. Let's plug in 12. Let's plug in 10. How can I solve for k? I'm going to times everything by 10. Very good. Ooh, yuck, gross, disgusting, nasty. Get rid of that fraction. And so I get k is 120. Then I'm going to use that with part 2 to answer the question. So, and someone said, do I use the same formula? Yes. Stick with the same formula. Y is equal to k over x. So find out y when k is 120 and x is 15. So y is equal to 8. Any questions on that? Good to go? I will say this while you're doing this. Remember how I said direct? If one goes up, the other goes up, and if one goes down, the other goes down? If two things vary inversely, how do they relate? If one's going up, the other goes down. Okay, so check this out really quickly. Let's compare temperature to ice cream sales. Okay, temperature outside to ice cream sales. Like go to Sweet Frog, go to Ben & Jerry's, go to Haagen-Dazs, go to Dippers, go to wherever your favorite ice cream shop is. Okay. As the temperature goes up, as it gets really hot outside, what happens to ice cream sales? They go up too. More people probably buy ice cream. Some of us eat ice cream year round, right? That's me. Okay, but probably more people buy ice cream in the summertime than in the wintertime. Okay, would that be a direct variation or an inverse variation? Are they going the same direction or different? If one goes up, the other goes up. That would be a direct. And you can reverse that. When it gets really cold outside and we're under like a freeze warning and school's called off late and it's like -8 on the mountain, tell me about ice cream sales. They go down. That's still a direct. Does that make sense? You can reverse it. They're still going the same way. One goes up, the other goes up. One goes down, the other goes down. That's direct. Let's take temperature to layers of clothing. Okay, got to keep your head out of the gutter for this one. As temperature goes down, what happens to your layers? They get thicker. What kind of variation would that be? That would be an inverse. You can reverse that as temperature goes up. Okay, people start to wear flip-flops, tank tops, shorts. You know, your layers go down because it's hot. Okay, that's an inverse relationship. Let's do speed of a car to time it takes you to get there. So the faster you drive, what happens to the time it takes you to get from here to there? It gets shorter. It goes down, right? Would that be inverse or direct? That would be inverse. You can reverse that. You drive like a grandpa or grandma and your speed goes down and you're driving 15 miles an hour. How long is it going to take you to get there? Your time is increased. So that's still inverse. So I do want you to understand with an inverse, if one goes up, the other one goes down. Or vice versa. If one goes down, the other goes up. Okay? Those two things would relate inversely. So you try this one on your own. All right, be careful. Was everybody able to get 15 for K? Yes. All right, be careful. Some people said, I just took 15 and divided it by 2.5, and that's how I got rid of the X. Be careful. Like, make sure you solve it mathematically and do your correct skills. You can't solve for X if he's a denominator. So the very first thing that needs to happen is you've got to get rid of X in the denominator. In order to get X by itself, he's got to get out of the denominator. Okay, so how would you get him out of the denominator? You would multiply by X first. Then, now you can get X by itself by dividing by 2.5 on both sides. So, how many of you just randomly, like, you took the 2 and divided them, and you didn't know why you were doing it, but you got a number, and there it was? Be careful doing that, Okay, make sure you actually solve it the correct way. Okay, because it may not always work if you're doing it like randomly. Any questions on that? Okay, yes ma'am. Totally, exactly. So if you would like to, and you want to use xy equals k, you could totally use that. Does that make sense? Sometimes I talk about that other formula and use whichever one, and then sometimes I just want to stick with one and not confuse people. But I totally agree with that. Okay, so let's go to joint variation. Joint variation is similar to direct variation. What does the word direct mean? I told you I wanted direct to mean times, inverse to mean divide. Joint is just like direct in the fact that it's timesing, but I think of it like the plural version. What does the word plural mean? More than one. It's being times to the x, but it's also being times to the z. It's multiplying, like I think of direct as like singular. You're timesing by one variable. Does that make sense? Timesing just to an x. Joint is just you're timesing to multiple variables. So I almost think of like this formula, just to give you an example, like a real life example of joint variation. I think of area of a triangle. Because first of all, do we always times by 1/2? Yay or nay? In 5th grade, did you times by, was it 1/2 the base times the height? In 6th grade, was it 1/2 the base times the height? 7th grade is 1/2 the base times the height. Like it's always been a half. So what would we call a half? He would be what? The constant, the number that is always there. You always, to find the area of a triangle, you take half of the base times the height. Okay? And this would be a joint example because we're not just timesing by one variable, not just by the base, but we are also timesing by the height. We're timesing by multiple variables. So that would be a very good example of joint variation, where you're timesing by multiple variables. Okay? So, let's check this out. 8. All right, suppose y varies jointly as x and z. So y varies jointly as x and z. Jointly means it's being times, the k, the constant, is being times to the x and the z. So y equals kxz. I want you to read this. Find y when x is 5 and z is 3. If y is 18 when x is 3 and z is 5. Which one is part 1? So I'm find y when x is 5 and z is 3. Is that part 1 or is that part 2? That's part 2. That's the second part. Here's your first part. If y is 18 and x is 3 and z is 5. So here's part 1. Let's plug in that. So y is 18, x is 3, z is 5. So 18 equals k times 15. And I'm going to divide by 15 on both sides. So k is equal to 6 over 5, 1.2. I prefer 6 over 5. So now let's use that with part 2. Y equals kxz. So y equals 6/5 times 5 times 3. So what's your answer? Fives cancel. So what are you left with? 18. And someone said earlier, they said, Miss Gordon, why did they just do the same thing again? Well, they didn't really, because then they switched the variables. But in this case, x times z is going to be the same thing as z times x. Like, it's not going to matter if you switch it around. Okay? It's not going to matter if you switch it around. So, all right. So you try that one, and then we'll go to the last type. All right. So what do we end up with? 30. Any questions? How many got 30? Good. All right, so here's where I'm going to leave you for lunchtime. I'll let you go ahead and copy that down, and we'll talk about combined when we get back from lunch. Okay, so we're back from lunch, and we're going to talk about combined variation. This is the last type, so let's review really quickly. Direct means the constant is being times by the x. Inverse means the constant is being divided by the x. Joint is just like direct, except it's plural. It's being times by lots of variables. And it can be more than just 2 variables. It can be times by 3 and 4. Think plural versus singular. Combined means we are going to combine direct and inverse. So in this case, and I did this on purpose in the PowerPoint, on this case, what's the relationship to the x? It's varying how to the x? Direct to the x being multiplied, and what to the z? Divided or inversely. So it would say that y varies directly to x, times by x, and inversely to z. Does that make sense? It's being divided by z. So let's look at example 7. Now this one it's flip-flops, so I want you to understand this. Okay? The definition I gave you just a second ago, I had it varying directly to the x. What is it telling us it's directly to now? It's directly to z and inversely to x. So I'll give you a second to copy this down, and then we'll talk about it. So remember how I said, like, don't get so involved with the equation like a minute ago? I gave you the equation, and it said y equals kx over z. Don't automatically just write kx over z. Okay? You have to read it. It may not always be using y's and x's and z's. It may be using other variables. So you have to read it. You have to understand it. So check this out. If y is direct to z, then how would I write that? I would say y is k times z. Direct means I'm timesing to z. Does that make sense? And it's inversely to x. So inversely means divide, so I'm dividing by x. Yes, I know this is backwards from what I just gave you, but I did that on purpose because I want you to understand that it depends on how it tells you that the variables are relating as to where they go. It's not always going to be kz over x, or it might not always be kx over z. It's how it describes it when it gives you the sentence. Does that make sense? So really understand that if it's direct to z, that means it's timesing to z. K is being times to z. And if it's inverse to x, that means K is being divided by x. So, part 1, let's plug in. Y is 16, Z is 2, X is 42. So, solve for K for me. What does K come out to equal? 336. Any questions on that? If it were me, I would times by 42 first, and I believe you get 672? 672, and you get 2 times K, and then if you divide by 2 on both sides, you get K is 336. So let's use that with part 2, using the same formula. So Y is equal to K is 336, Z is 8, and X is 14. So what would Y equal? 192. Any questions about that? Nope. All right. So you try this one on your own. You should be able to get it done in class and study hall. So what does X equal? Negative 5 over 4. Any questions about that? Did that go too quick? Did you mess up? My question is, does it have to be where you didn't get rid of the X? Okay. You could, and then if you turn around and divide by 5, it's just going to give you negative 15 back. Like if you times this by 5, you get negative 75 equals 5K. And then if you divide it by 5, if you divided negative 75 by 5, you get negative 15. Yeah. Yeah. All right. Any questions on direct, inverse, joint, combine? Memorize them. Yes, sir. No. That's why I said you have to read it. Like some people, like, how many of you used to, like, you just look at your notes and you just copy the example before exactly how it was done, and that's how you solve the next one, right? Anybody ever do that? Like you look back to your notes and you just basically copy the steps and that's how you do it? A lot of us do that. Here's why I'm telling you is you've got to be able to read it. Like I might say, if H varies directly to P and inversely to, give me another variable, B to B. How would we set that up? If H varies directly to P, we would say H equals KP. It's timesing to P. When I say it's, I mean the constant. K is timesing to P, and if it's inversely to B, then it would be divided by B. Does that make sense? It's how you read it when it gives you the statement. What if I said it's direct to Z and direct to X? What if it's direct to both? So then what kind of variation is it? Well, sort of. It's direct to both, but if it's direct to both, we would call it joint variation because it would be multiple variables. If it's direct to this, timesing to this, and timesing to that, then it would be joint variation. Does that make sense? So I do want you to understand that know the words direct means timesing to the constant, and inverse means dividing to the, and you just have to read it and be able to be versatile with your variables. All right, last thing I want to look at real quick. I want to know, is it direct, inverse, or combined? And then I want to name the constant of variation. What's the constant of variation? What's the constant? What do we know the constant as? What doesn't change? Which variable would that be? The K. That's all I want you. I want you to tell me, what's the K? Okay, the number that doesn't change. I agree. So let's start in the order that we learned them in. Okay, let's start in the order that we learned them in. How about direct? The pink one, P equals 4S. Singular, timesing by one variable. Okay, and so this would be direct. What would the constant be? K would equal, if this is Y equals KX, which one's the K? 4. It's the number, you're always timesing by 4, no matter what the P and the S are. In that particular problem, you're always timesing by 4. Okay, so let's go to inverse. Inverse means division. Which one's being divided by the X? Yeah, the yellow one. L equals 5 over K. So there's your inverse. What would the constant be? It'd be 5. 5, we're always dividing 5 by the K. Okay? Does that make sense? It's the number that doesn't change. All right. How about joint? Joint is just like direct, except it's got lots of variables. It's timesing to everything. It's the blue one. So this would be joint. And what would K equal? 8. That's your constant. You're always timesing by 8. No matter what the W is, no matter what the Z is. Timesing by 8 every time. And that makes the black one combined. Notice what's the relationship to the B? It's direct to B and inverse to C. It's dividing by C. So what would the constant be? 5. The constant would be 5. Okay. Here's what I want to do. I want to show you this because this was tricky when people got this today. So I'm going to take a look at one that you have on your page. Let's look at this one. C over D is equal to pi. First of all, is there a variable that is by itself? Is my variable by itself? No? So solve for one of those variables. What would be easy to solve for? C. How would I solve for C? So here's what I want you to understand. Before you label it, direct, inverse, joint, combined, solve for a variable. And so I get C equals pi d. What kind of variation would that be? The direct. Very good. What's the constant? Pi, because we use pi is a number, 3.1415, blah, 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 blah. It's a non-terminating, non-repeating decimal, but it's a number that we use every single time. So pi would be the constant, but do you understand you had to solve it first for a variable and then state it? If I had one that looks like this, what if I had xy equals 7? Do I have it solved for a variable? So let's solve it for, you got to solve it. Get a variable by itself first, and then tell me what kind it is. So solve this for y. What would I do to both sides? Divide by x, so get y by itself first. Now, what kind of variation would that be? Inverse. Does that make sense? So I'm going to tell you on your homework, if it's not solved for a variable, if you do not have a variable that's by itself, you've got to do that first and then state what kind of variation it is. Okay?